All right, so we'll go ahead and get, oh yeah, we need to do your project. So, you've done your 2 projects. Well, hopefully you're almost done with project 2. Project 3, conceptually, is going to be a lot easier to deal with, but it's going to be a lot more research. Mainly because I'm going to allow you to copy whatever you want from the internet.
What?
You may copy whatever you want from the internet. But then, of course, there's a cost to that, but we'll get to that.
Yeah.
So, in our labs, we've talked about unbalanced binary search trees. And let me give you a quick review of what balanced and unbalanced are, since I'm sure no one has that perfectly in their heads, or do y'all?
Oh, totally.
Totally. Thank you. I'm so glad. Will you draw me one up on the board, Caitlin?
Nope.
Good morning.
Morning.
Oh, nice haircut.
Thank you. I like yours.
Oh, good. I'm glad. All right. So, give me some numbers.
15.
15.
I'm always first. 12.
5, 12, 2,
65.
65.
Wait, why is 12 rated?
Boom. Fix that. We'll put 13 here, and then we'll put 10 right here. All right. This tree is balanced because basically every level is full except for possibly the last one. Actually, this one's perfectly balanced. If we put a 3 right here, it's still balanced. If we put a -5 right here, it's still balanced. But if I were to put a 4 right here, it would be no longer balanced because you have basically 2 levels that are not full. And with a balanced, it can only be the last level that isn't full, so to speak. Okay? Why would we want our trees to be balanced?
It's easier to deal with.
Easier to deal with. What do you... I like how you put that. What do you mean by that? How does that make you feel?
Well, it would be, if it was balanced, it's prettier.
It's pretty... What is if it's unbalanced, what could possibly happen to the tree?
Sadness.
Sadness, right? What type of sadness?
Lots of it.
Lots of sadness, all right? What exactly could happen to the tree that would make it slower?
You couldn't search, like, down the tree. You'd have to search everywhere.
Okay. So let's take, for example, I mean, this over here is a binary tree. Another binary tree would be, we had 65, and then 15, then 13, then 12, then 10, then 5, then 4, 3, 2, and then -5. Is that a binary tree?
Yes. It's also a linked list.
It's also looks like a linked list. So if you were to search something in this structure, what would be the runtime complexity of this? O of n, right. But if it was balanced, it would be log of n. So the point of having a balanced binary search tree is to make it so that when you search, it's log of n at all times. Okay? Any questions on that? Great. So,
It's going to be a quiet day today.
yeah, well, you know, it's back from
She
spring
won't
break.
be back until later tonight.
Was she the one that causes all the problems?
No. We caused them together.
Okay, good. All right, so we've only talked about unbalanced search trees because we haven't talked about balancing. There are numerous algorithms to balance trees, namely AVL is the common one. Red-black is also a well-used one, but there's also Scapegoat, 2-3, AA, Splay, Treep, and there's probably a ton more that I haven't even encountered yet. Your project is to first pick 2 of them and then research where you think one would perform better than the other. For example, one of your trees may do better on inserting, and another may do better on deleting, or one may do a better job of balancing, so then searching becomes a faster option. But basically, these trees are not going to behave perfectly the same. Some implementations are better than others in certain situations. I'm going to ask you to go and research what those situations are. Keep in mind that for this project, you may use the internet. You may literally go out and copy people's implementations of AVL, Red, Black, Scapegoat, 2.3a, Splay, and Treep, and copy and paste them in. I am 100% okay with that for this one project.
Is this the last project though?
No.
What?
Really?
I thought there was only 3.
No, there'll be another one.
I'm still in the middle of the second.
Yeah.
Exactly.
All right. One thing I want to warn you about is I've had a lot of people choose red black, probably because it's the second one listed, and they always come back to me and they find out that the implementation on the internet is completely wrong.
Isn't there a saying when it comes to snakes, red and black, friendly Jack, red and yellow, deadly fellow?
Yeah, something like that. So you may go ahead and choose red black. I did have one student finally get red black code working, but you may want to choose a different one. Just because I've seen some horrible or a lot of issues with red black.
Where do they get these names from? Like red, black, scapegoat?
Oh, maybe I should ask y'all to put a little paragraph explaining that.
No.
But AVL is
Thank you.
basically it's the last name of the 3 people that developed it. And then red black is because you're going to color your nodes either red or black, and then depending on when you're doing an insert or deletion on a red or a black node, you have 2 different things you do.
Okay.
And then, yeah, from there, I forgot what scapegoat was. Yeah.
Tattletale?
You pick one to be the scapegoat, right? I don't remember. 2.3 is because it's a B plus tree implementation, but with only 2 children, but you can have a 3rd one, so yeah. Anyways, and I like AA because it has a different meaning. But anyway, splay and tree. Basically, I want you, here's a version of the binary tree code. You may use this, you may not. I don't actually care. I'm giving you some code in case you wanted to get something to start with. But you want to make sure that you can put or insert into your binary tree, find out what the height is, ask if it contains something, be able to remove from it. And you may want to do some in-order, pre-order, and post-order just to test to make sure it's working properly, and then, of course, free the memory. Here's one place that had I think it had a good implementation of AVL and a poor implementation of red-black. The main purpose of this is once you get 2 trees working and you believe they are correct, you want to describe one situation where each balanced tree implementation is better than the other. So you're going to have 2 situations in total. One where your first one's better than the second, and another where the second is better than the first. These metrics could be insertion, retrieval, deletion, memory usage, or any other functional test. You may come up with some random function where one behaves better than the other. That's fine. As with most metrics, make sure you have a line graph, the size of the tree on the X and time on the Y. Hopefully y'all have had some good practice with generating these graphs by now, so you hopefully won't have too many issues doing this. Of course, write some test cases, and don't forget about memory management. You do need to make sure that you do free all your memory correctly. Valgrind. Yeah, turn in. It's due 3 weeks from today. There is no teamwork, but you may use the internet. Just make sure you cite your resources. Okay? Yes.
Now, this may be a stupid question, but I probably know the answer. Do you want an APA format to cite the code, or?
I don't care.
Alright.
That's nuts.
Literally just put the link to the website.
Literally, just put the link.
Sure.
It's a website. Yeah, it's a website. This is not a. I'm not asking you to write a dissertation here. So, but.
You'll never know with professors nowadays.
Oh, okay. Yeah. It's fine. Just give me the link. Make sure you cite it somehow. And be consistent in your citation. That's the most important thing.
Mm-hmm.
Don't cite one way and then cite it differently another way. Don't just be consistent. Yes.
What about changing variables?
In their code?
Yeah.
Yeah, I mean, that's fine. Just, just cite that, hey, I got this code from here. And then if you change the variables, I don't care. That's fine.
Okay.
As long as you said, hey, look, I got it from here.
Also, for lab, what was it, 14, the lab due before break, I know we're kind of going off topic, but were you messing around with the autograder over break?
Something happened to the autograder. Don't know what happened.
It broke.
The machine froze. Well, part of the machine froze. So it's up and running now.
Okay, because I was like, I was doing
Probably because I was running 4 VMs on it through VirtualBox, but
Probably.
Wow. Okay.
oh yeah, it's running 4 VM. It was 4 VMs, and then doing the autograder as well. It's actually doing pretty well for a long time.
It only just went down.
It only just now had an issue. Yeah.
But because like I was doing all the tests and I was creating like different functions to put into the functions that you were testing.
Yeah.
All of a sudden it's just like it is not clear what this function does. I'm like I'm doing an integer return of 2 maximum numbers. I don't know.
The autograder or
Yeah, the autograder wasn't recognizing one of the functions. Like you
Oh.
were testing, like not that not that you were testing, but I put in a function that I created outside of the function that you were testing,
Mm-hmm.
and it just gave me an error. I'm like, what are you trying to do? What are you trying to tell me?
Well, the autograder is up now. You can ask me after class. But first, any other questions about this project?
No,
Nope. All right, great.
We're gonna die. Okay.
it's sadness.
This is the easiest one. It just takes time.
You said this one